my pleasure to chair this first session, which deals with a very global, the most global issue. First speaker will be Frank Lecocq, who is an economist from CIRED, and CIRED stands for the French International Center of Research on Environment and Development. I think what is important in this case is that he is one of the authors of the IPCC report, Working Group 3, for those who are already experts in this domain. And this Working Group 3, the mission of this Working Group 3 is to try to put as many or most important experts together in the world and discuss on what are the important policies to mitigate the problem.
Thank you very much for the invitation and for asking me to set the stage a bit by presenting some of the key insights from the recent, it was published in April 2022, report of the IPCC Working Group 3 report. So as you know, IPCC has 3 working groups, and Working Group 3 is on mitigation. So I will focus on that particular topic. But there are also other elements on adaptation from Working Group 2, which I'll very quickly touch on. As was already said before, I'm standing alone in front of you, but the work I'm going to discuss is actually a collaborative work. We were 278 authors for this from all over the world, and the construction of a report has spanned over more than 4 years. It was delayed a bit because of COVID. So it's a huge endeavor, and I'm only one tiny part of the contributions that have led to this material. To give you an overview of what's in a report like this, basically the overall objective of Working Group 3 is to analyze and provide an overview of what the science tells us about opportunities and abilities to mitigate. Okay, so chapters. So you have basically chapters 2 to 4 that are about trends, past trends in emissions and future trends in emissions in scenarios. Then chapter 5 to 12 are about mitigation options, really per se, sector by sector or system by system. You can see energy, urban, buildings, transport, industry. FLU, that's actually agriculture, forestry, and other land use. You have a new chapter that was not in the previous reports on demand side options, services and social aspects of transformation, chapter 5, and chapter 12, which is basically everything, all the other things that have not been discussed in the previous ones, notably direct capture of carbon from the atmosphere, and also all the elements associated with food systems that are in 12. And then, really, I think relevant for this conference are chapter 13 to 16. But okay, now what are the conditions under which these options that are out there can be put in place in the real world, or scaled up when they are already in place, depending with discussions on the policies at the national and subnational scales, international cooperation, chapter 14, finance, obviously, and innovation. And finally, chapter 17 sort of embeds all this discussion into the broader context of sustainable development. If I have just one message, it is that please open this document. And so it can be a bit intimidating because it's 3,000 pages. It's quite thick. But we have put a lot of signposts everywhere so that you can orient yourself and try and find material. I think it is still relevant. It's 1 year old. so it's not too old, and many of the material that is in there is still correct. There are also summaries. The summary for policymaker, which I'm not sure I would encourage you to read because it's been so discussed in the, with the countries overlooking the IPCC that the writing is very dense and it's not very clear. Or a technical summary that is a bit longer and much clearer, and the full report. So what's in there? Let me start with if you look at what's out there at the moment, so the photography, we see increased evidence of climate action, and the statistics that to me is the figure that is the most important here is that more than half of the world's global greenhouse gas emissions are actually somehow under some form of jurisdiction and under some form of policy already. Obviously, this is not enough. This policy is not strong enough, but at least there's a framework already in place. What we've seen also in the recent past is a rapid decrease, and actually faster than anticipated decrease in the costs of the unit cost of some of the key technologies for mitigation, notably photovoltaics, onshore wind, or batteries for electric vehicles. And this decrease, more than 85%, for instance, in the unit cost of PV over the past 10 years, have led to rapid adoption and rapid penetration. So you can see the curves here. However, they look very impressive, but if you look at the scale on the left-hand side, it's not so impressive, because when you start from zero, even if you have an exponential, you still it takes some time to reach very high levels. And despite all this, what we see, the data shows that the emissions are still growing, and they have still been growing in the past decade at a rate slower than in the previous one, only 1.3% per year instead of 2.1. But still, in 2019, which was the last year that we had data when we wrote the report, the world emissions, greenhouse gas emissions, were at an all-time high of 59 gigatons CO2 equivalent. And unfortunately, despite a drop in 2020, there's been a rebound, and we are still at those around those levels in 2021 and 2022. So unless there are immediate and very deep emission reductions across all sectors, the objective of keeping warming not too far around 1.5 C is clearly beyond reach, and even 2 C is we are not on track to get to 2 C. In fact, if you now look ahead at what the scenarios the literature tells us about the future, well, if we keep current policies, the scenarios that are in the literature and that are summarized in this figure show, and this is the horizontal red shape on at the top of the figure, that emissions are projected to stay so more or less constant over the next decades. So this is not scenarios with high increase in emissions, but still this is way too much greenhouse gases in the atmosphere to keep warming below 2 C. Those trends, if you continue those scenarios until 2100, you get to things around 2.6 and 3 Celsius. Obviously, that's with a big uncertainty. Now, conversely, if you really wanted to keep warming below 1.5 with no limited overshoot, you need to be on the blue lines at the bottom of the figure, meaning reducing your emissions by nearly half by 2030 relative to 2019. Not only CO2, but also, this is CO2 reduced by 43%, methane by 33, which is extremely rapid extremely rapid and a very strong change relative to current trends. Even if you want to stay below to see, well, you would have to reduce your emissions by about a third by 2030. You can that's the green lines on the screen, and the purple one shows where we might be in 2030 if countries do actually implement their nationally determined contributions, so their pledges under the Paris Agreement. Those were the nationally determined contributions available at the time of writing. There have been new and updated ones since then. So I think, but still, I mean, with the message is that if countries implement their NDCs, that would be a departure from current trends. So there's an effort. However, that effort is insufficient and it's not consistent with even 2C. You could still reach and stay below 2C because what matters ultimately is basically the area below the curve. So the total amount of CO2 you emit in the atmosphere over time. But that would require a break in 2030 and an acceleration at unprecedented rates at that point. The other message from the long-term the scenarios is that if you want, whatever the level at which you want to stabilize your temperature, you need to reach at some point net zero CO2 emissions. And obviously, the lower the temperature you want to reach to limit global warming to, the earlier net zero should be reached, around 2050 for 1.5, around 2070 for 2 degree. Remember, that's net zero for the whole world. So that's the. Now, the second part of the report really looks at what are the options. So it's, as I've said, the bulk of the report is actually devoted to looking at the scientific literature sector by sector to look at what the options for mitigation. And the key message here is that there are actually options available, that are not science fiction, but that are actually tested and feasible. That can either put all together, divide by 2 the emissions by 2030 relative to today, so even consistent with 1.5, and all that at a reasonable cost, reasonable being below $100 per ton CO2. So that's really an important finding. However, once I've said that, the challenge remains just tremendous, because the first thing is that there's no one single technology, one single option that would solve it all. Just put renewables and that's it, or do stop deforestation and that's it. No, you need to work in all the sectors at the same time and to add up. So energy, land use, industry, urban, buildings, transport, etc. The second key message, and that makes it challenging as well, is that you need to do that. It's not just technology on the supply side that will solve that's not enough. You also need to reduce or to limit demand and to work on both supply and demand at the same time. And that's why demand services is actually on top of these others. And obviously, the third challenge that I've already outlined is that you need to do that at the world scale to actually limit and reduce your emissions, given that means the total emissions that do matter. The report goes on by analyzing sector by sector what are the key sort of mitigation opportunities and challenges and opportunities. I'm not going to look at all of them. I mean, it's just it would take too much time, and you will find that in the slides. I hope they can be circulated, and also in the report itself. Just to point just a couple of examples in the energy sector. Well, Major transitions are obviously required to limit global warming. A key issue is the reduction in the use of fossil fuel. I mean, if you take the existing capital stock in terms of existing stock of power plants, and you assume they will run until their expected life for the expected lifetime, then you will emit more CO2 in the atmosphere than the total of the maximum budget for 1.5, and about as much CO2 in the atmosphere as the total your total budget for 2 degrees C. Said differently, you cannot reach the 2 degree, let alone 1.5, if you do not shorten the lifetime of existing capital stock and existing power plants, which is obviously a huge challenge. So there are many, the chapter on energy shows also many pathways towards low or no carbon energy systems, depending on the geography, the economy, the resources in the different economies. However, they all have elements in common, notably widespread electrification, coupled with green electricity by renewables in particular. Very strong push for energy efficiency throughout the systems. And when electrification remains difficult, use of alternative fuels, notably hydrogen or sustainable biofuels. Maybe I'll just skip this one, just say a couple of words about the demand and services chapter. So as I said before, this is a chapter that was new in the sixth assessment report. Not that previous literature did not look at demand side measures, but previously those were discussed in each of the sectoral chapters. And in this case, this has been there's been a separate discussion, which has sort of tried to sum up what we know about these options. And what they find, although adding up all these things is difficult, is that the potential is huge to reduce emissions from 40 to 70% by 2050. Okay, with many sort of options out there, from walking and cycling, electrified transport, reducing air travel, etc. The point here is that we tend to think about demand and services as really actions by individuals. However, a lot of what you will see in this chapter is actually about public policies and about infrastructure. Because obviously, you may want to take your bike to work, but if you do not have a bike lane, well, maybe you're not going to take it. Or if anyway you don't have housing that is close enough to your affordable housing that is close enough to your work, well, you're not going to take your bike either, even if you really want, you have a desire to do it. Meaning that lifestyle changes go on in hand with actual public policies and public decisions, notably on infrastructure. And a lot of this chapter is devoted to. Second key message from this is that there are arguably all over the world millions and millions of people who do not have live a decent life and do require additional housing, additional energy, additional resources, meaning that their footprint in terms of material and emissions would also and should also increase. And there have been some questions as to a lot of debate in the literature as to whether that objective, poverty alleviation and increasing living, was compatible with deep mitigation. The response from the literature is that yes, this is feasible. There are ways by which one can have global reductions and deep reduction in emissions globally, yet increasing consumption and environmental footprint from the least, the poorest in the world, meaning that the richest who have the highest potential to mitigate in that sense would have to take make stronger efforts. I'll skip looking at the time. How much time do you still have? 10 minutes. Good. So maybe I'll skip the sectoral discussion, and we can come back in the questions. And since this is an audience where there are many economists, just to provide to spend a little time on this figure, which basically sums up what we've seen before, but also bridges to the question as to the obstacles. This is an overview of the mitigation potential and the associated costs until 2030. I'm sorry, this is very small, but this is in the summary for policymaker. You have by big sector, energy, land use, you have the different options, say wind, PV, biomass, hydro, geothermy, etc. For each, on the length of the bar represents an estimation of the potential of mitigation in gigatons of CO2 per year until 2030, and that is important, as the literature tells, as given by the literature. With uncertainty bars that are, as you can see, quite large. And also the color on each of the bar gives you a sense of how much of that potential is at low, medium, or high costs. This is based on bottom-up literature on mitigation costs. So this is sector-by-sector analysis of the cost of putting wind, solar, putting biomass, putting more hydro, etc. So since this is bottom-up literature, this does not not take very well into account system effects. For instance, if you have renewables, well, you also have to connect them to the grid. You have all sorts of interrelationships between your renewables and the rest of your electric system. That is not certainly not the cost of that, are not fully taken into account here. Also, this is for 2030 only. Which explains why, for instance, the bar for potential for mitigation based on nuclear is so small, because simply you cannot imagine there are very few reactors that new reactors that you can imagine putting in place by that time. There was an attempt at doing the same graph for 2050, but the data was not just that was not enough. There are not enough data to put it all together. So clearly, this figure is no blueprint for action. It cannot be used as saying, oh, we should start with this and that and that. However, I think it is interesting to spend 1 minute on it for two reasons. One, it shows that the diversity of the potential, and that if you want to do big, you have to add up many of these bars. Apart from the couple of them, if you really want to reduce deeply your emissions, you really need to go into many of these options. That's point one. Point two is the important the number of bars where you have blue colors. Blue color means you have actually a negative estimated by negative costs of mitigation, meaning it would be actually cost effective to do those measures. Yet the potential is untapped and those measures are not put in place. Why? Well, either because there have been new developments. For instance, the PV, there are probably many areas where PV is now cost effective, but yet has not been installed. It's just a matter of time. But in many other areas, the blue, it simply means that the cost-benefit analysis does not capture all the barriers and to implementation. For instance, energy efficiency. It is well known that energy efficiency in building is not put in place at as much as just basic cost-benefit analysis would suggest, because of landlord-tenant dilemma, because of information asymmetries, etc. There are many reasons. So it means that in terms of public policy and obstacles to lift, it means that it's not because you have a blue that, oh, it's costless and it's going to happen, but it means you have to think about each of these, identify the obstacles, often institutional, and then lift them. And that's I think an important element. Not just about money, but also about institutions, organization, and structure. Let me conclude with some of the elements on the barriers, which I've already started to discuss. So chapter 13 is really dedicated to the policies, regulatory, and economic instruments. And really the key point here is that we now start to have some experience from which we can draw empirically. And one of the key messages is that there's a lot of diversity of experience. However, policy packages, economic work packages that are able to achieve sort of systemic change seem to be relatively to work in many cases. Also, lack of coordination across government levels are really identified in many jurisdictions, many countries, as a key impediment to accelerated mitigation. In terms of investment and finance, well, it's difficult to estimate the amounts, the current amount of financial flows towards mitigation, I mean, to separate it from other type of investments. But the general idea is that current financial flows are not at the scale that would be needed to see, let alone 1.5. The point is not so much lack of global capital and liquidity, but rather directing this capital towards low carbon investment that are often considered as riskier than the high carbon ones, with a particular challenge for developing countries where domestic savings may not be sufficient relative to the needs, and where therefore international capital transfers become important. Last but not least, mitigation has impacts obviously on other development goals, and there are obviously tensions or risks as here. We know that accelerated mitigation is required to meet other sustainable development goals. I mean, if we leave global warming unchecked, then we put at risk zero hunger, no poverty alleviation, etc. Yet at the same time, reducing emissions cannot but have also implications and negative implications for the economies. The literature on the macroeconomic impacts of mitigation suggests that their consequences on GDP growth in particular remain relatively modest relative to baseline trends, even though there are a lot of variations across countries here. Similarly, for employment, the studies suggest that the net impact of mitigation on employment remains limited, even slightly positive in some cases. But of course, that's an aggregate number, and you have all regions and sectors that lose, all regions and sectors that gain. There are a lot of disparities here, and issues associated with just transition, so how you train, how you compensate people that are losing in that shift or transition is important. Conversely, mitigation and adaptation as well have positive co-benefits for other SDGs, and Chapter 17 really looks at that at that literature in a lot of details. And finally, last idea I wanted to put forward is that advancing towards the achievement of other sustainable development goals may yield also mitigation benefits. I was mentioning housing before. Having decent, affordable housing not too far away from one's job is an objective that many societies give themselves, completely independent from climate. Achieving that objective or getting closer to that objective would mean shorter transportation time, make it easier for mass transit to be cost effective, or even make it easier to switch to other forms of mobility, bike or even cycling. So it's one example where achieving you can have the co-benefits of mitigation for other SDGs, but achieving other SDGs may also have co-benefits in terms of climate mitigation. I'll stop here to say that I think the key message is that there are elements out there, and that's why your initiative is really timely. It's not that we lack ideas on how to reduce emissions, but it's how we put them in practice and scale them up that is really the critical issue now. Thank you.